Okay, so in this third formal lab, our goal was to try and find the identity or the metal that makes up some pennies. And I told half the class to find the identity of the model that made up pre-1982, and I told the other half of the class to find the identity that made up the post-1982. Let's just say we have some pre-1982 pennies here. That is supposed to be a penny. Don't laugh. So we talked in class also that the density of a substance is its mass to volume ratio. And here, this line here is where we get that word ratio. So it doesn't matter about how much of the substance you have when we're talking about the density, because if the mass goes up, the volume will go up. And if the volume were to go down, the mass would go down. So whether you have a big piece of aluminum or a small piece of aluminum, the density of aluminum is always about 2.7 grams per milliliter. So let's say we had these pennies and we wanted to know what metal they're probably made of. And again, we have to use the word probably because we might have some error involved in this lab. So let's go ahead and find the mass and volume of 25 pennies. Now, the benefit of doing 25 pennies is that when we go to find the volume in a graduated cylinder, and you're wondering again, why is the graduated cylinder so wobbly? Like, I don't know. It just is. You can see the volume change a little bit more easily with 25 pennies than you can 1 penny. So in this lab, I'm going to go ahead and take all 25 pennies and I'm going to go to the electronic balance and I'm going to put all 25 pennies on there at once. Okay, so here's a pile of 25 pennies. And all those pennies combined read 71.28 grams on the balance. Now, we may not have calibrated that balance at the beginning of class. These pennies probably have some sort of oxidation, some dirt on them, some dust. So they're probably pretty dirty. That could change the mass maybe. So there's some maybe sources of error you can consider in this lab. Now, to find the volume of these 25 pennies, I'm going to fill a graduated cylinder up about halfway with water. Now, let's say I get about 50.2 milliliters. Notice that I'm going to the tenths place again because this was probably a 100 milliliter graduated cylinder. So now I plop in my 25 pennies. Now they get in there. Okay, there's my 25 pennies. And now the volume increases, let's say to 58.3 milliliters. And again, going to the tenths place because this thing measures by ones, the graduated cylinder. So now what I'm going to ask you to do is to find the volume of the pennies, all 25 pennies using these two values here. And then you were just given the mass of the 25 pennies. So I want you to find the density of the penny metal. And once you found the density of these pennies, of that metal, I'd like you to go back to Google Classroom. I'd like you to click on the lab, and I'd like you to look at that chart. I'd then like you to compare your value to these values and just pick something that's closest. Now again, maybe we made a mistake, but all you can do is pick what's closest. And at the end of the lab, I asked you to calculate the percent error. When you're going to calculate percent error, the formula is you take your value that you measured in the lab, your number, let's just say, and from that, you're going to subtract the actual value. So this is whatever it was on the chart there that we just looked at. So this is the number on that chart again. And you take this difference, and technically we just do the absolute value. But if this is ever negative, it just means that your value was less than expected. It doesn't mean it's a negative percent error. And you divide that by the actual again. So you always use the actual twice here. This is going to give you some sort of decimal place. And what you're going to do now is just multiply that by 100. And that's just going to tell you how far away you were from the real value. So that's kind of how you do percent error. The kind of interesting thing about this is I want you to think about doing sig figs and make sure we do the sig figs with the subtraction and then apply that to the division. So kind of a little attempt for us to practice, to learn something new with percent error and then to practice an old concept in significant figures. So let's use this data to answer the lab and or refer to if you had any issues with the lab. Hope this helps.